My name is Max. I work at Connext. We define ourselves as the HTTP of Web3, which means we built a secure communication protocol between cross-chains that is able to perform cross-chain execution. And I'm going to deep dive into that and explain what are cross-chain applications and why we believe they're really the next wave of innovation for the space. So first of all, we need to talk about what are cross-chain applications. We call them xApps. And they're a big difference between the current state of dApps that are basically multi-chain. So a multi-chain dApp is a dApp that is deployed on multiple chains with separate, isolated instances. So the same code is replicated across the different chains, and they work in a very isolated manner. Typical example is our friends at Aave. They have deployed on multiple chains, and each chain has a different lending market, is a different money market that is isolated from the other ones. Which means that as a user, I need to look at the different opportunities on the different chains, and then if I want to use one of them, I need to bridge my funds there, I need to take care about the gas, and that obviously introduces a lot of friction for less technical users. A cross-chain app, on the contrary, is an application that is able to interact with different chains at the same time, and these chains are interconnected with each other in a very, very secure way. An example is FujiDAO, Fuji Finance, which built a cross-chain lending aggregator protocol, which means they are able to tell the users, hey, you want to deposit a collateral, which is ETH, for example, you want to borrow some tokens, like USDC, they will find the best opportunity for you across the different protocols, whether it's Compound, it's Aave, or another one. But they will also find the best opportunities across the different chains. So your user do not have to think about what happens in the background. You can just select what are your priorities, and then the protocol, Fuji in this case, will take care of you, will take care for you of spotting the best opportunities and moving across the different chains. So why are xApps necessary? As you know already, we are living in a multi-chain world, meaning there are already plenty of layer ones, and we are coming to a new area where spinning a new layer 2 is getting very easy, and so we're going to see hundreds and thousands gradually of new layer 2s and layer 3s. They will gradually create a very, very fragmented user experience. So the liquidity is going to be fragmented across the different chains and layers. The user is going to have to be able to manage all the different chains, and this is, of course, like creating more friction and actually reducing the possibility for new users to get onboarded in an easy way. So why do we need these cross-chain applications? Well, the idea for builders is that with the cross-chain app, with a xApp, you can actually access the users, the liquidity, the data that are present on every type of ecosystem, on every type of chain in a secure way. So if you want to integrate a protocol that is deployed on a different ecosystem to where you're deployed, you can now interact with it. If you want to access its liquidity, its data, you can do it. If you want to onboard users from a chain that where they have funds, so if a user has funds on a different chain to where you are deployed, you can now do that. And this kind of produces a new level of experience for our retail users, for the ultimate consumers of these applications, where they don't have to think about it. They don't need to think about on which chain an app is deployed on, compared to the chains where they have deployed, where they have funds, where they hold funds. Because the whole experience, the whole cross-chain experience can be abstracted for them. The whole chains, the whole technological stack can actually be abstracted for them. And that simplifies extremely the overall experience. And if you think about it, that makes total sense. Like if you're going on YouTube, all you want is to watch your favorite cat video. You don't care about which cloud provider the website is using. You don't care about on which storage the video is actually hosted. All you want is to have an experience with your application. So why is Web3 not providing the same experience? We need to get there, and that's how cross-chain protocols empowers you to create these type of experiences. So we really want to go to a situation where a user needs to open MetaMask, open his favorite wallet, and select the network where he needs to go to, think about the gas, think about how do I get there, think using a bridge UI, to actually creating applications that tells you, hey, you have some tokens, wherever they are, with one click, you can deposit into our vault. And this is the case for Min Finance, which is another project that is integrating with us that allows you to do DCA, dollar cost averaging operations, in a very simplified way. So now the question is, okay, I like this idea, I like this approach, I like the idea of abstracting the chains and creating these cross-chain applications. I can see the utility, but is cross-chain, like, of course, cross-chain introduces new type of risks. So can cross-chain really be secure? Because, of course, now we have this, almost secure, like, let's say, relatively secure ecosystem, the different blockchains that exist, but they are disconnected from each other. So is it possible to connect them in a secure way? Otherwise, all of this doesn't make sense. And for cross-chain, all you have to think about it really is, who has the power to rug me? Who has the power to steal my funds? And how much does it cost to corrupt me? And so over the course of the last years, several solutions have been created, and each of them has their own trade-offs. So I've kind of like categorized them into broad categories. This is simplification, but it kind of like helps you to understand what are the different trade-offs in the space and how we're trying to overcome them. So the first category, we call them native bridges, and it happens where all the validators on one chain are validating the transactions on the other chains. And these are the examples of Cosmos and the IBC protocol. It's very trustless and very trust minimized. An example of these are rollup bridges, where all the Ethereum validators are validating the smart contracts for the rollup bridges. So this is a very secure way to perform cross-chain transactions, to move between ecosystems. But they have an issue. The limitation is that this type of communication is not generalizable, meaning it's very specific on a certain path. For example, if you want to go from Arbitrum to Ethereum, or to Ethereum from Arbitrum, the native rollup bridge between Ethereum and Arbitrum is trustless, is very secure, but it only works for the path between Arbitrum and Ethereum, right? So you need something that is more generalizable. So other projects have started saying, okay, let's create an external entity that basically is in charge of validating what happens on one chain, and then can let something happen on chain B. This is the case for multi-sig bridges, for example. This is the case for a set of external validators. This is the case of bridges that are powered by oracles. What's the issue? Is that in this case, you're creating a third party that actually becomes in charge of validating these cross-chain transactions. And the third party is not as secure as Ethereum, of course. Like, it's not as decentralized, it's not as trust minimized as the big blockchains. So it becomes a point of attack. And if you think about it, like if a bridge has locked, I don't know, 1 billion in value, and all it costs is to buy this token for 50 million, 100 millions, it just becomes an economic calculation to say, okay, that's how much I can access by hacking this bridge. And if 100 million sounds a lot to you, think about the power that a small government or a big corporation can have, and they have this economic possibility to actually attack this type of infrastructure. So the issue with this type of bridges is that they're not trust minimized, they present a centralized single point of failure, and therefore they're not the right solution to go for. A third type of bridge is what we call optimistic bridges. So these they are based on the principle that it's impossible to verify that something that has happened on one chain is valid from the other chain. But what you can cryptographically verify is that from chain B, I can actually demonstrate that something didn't happen on chain A. So the idea of optimistic bridges is that I can bring a transaction from chain A to chain B, and this transaction is quarantined for a certain amount of time, let's say 30 minutes, 1 hour. And during these 30 minutes, any watcher, anybody who is watching the chain, can come and say, hey, this transaction is not valid, and slash it. So there's a very secure architectures, because all you need is one good actor monitoring the space, watching the chains, that is able to say, hey, I am not, this is not true, this is not correct. And so the transactions get slashed. What's the trade-off, of course, with this type of bridges, that they have latency. So you need to wait these 30 minutes. You need to give some certain amount of time for the watchers to come and prove that it's not a valid transaction. So how are we trying to solve this? We built what we call a modular system. that basically breaks the bridge into different layers. The first layer is what we call the transportation and verification. So we looked at the space and said, okay, what's the most secure path that exists today between, I don't know, to a rollup, for example? Well, it's actually the same rollup bridge. So we plug into the same rollup bridge, and we use that to communicate between the different chains using Ethereum as a hub. And when that is not available, we have an optimistic system on top of it that connects, I don't know, two different layer ones where there is no native bridge that will be trustless otherwise. And so this creates another issue, which is the latency, as we said before. So we created a third layer on top of it, which we called a liquidity and execution layer, that where basically there are liquidity providers on the receiving chain that said, hey, you users should be waiting for 30 minutes before having your cash or your tokens on the receiving chain. We will give you the cash for you in exchange for a macro commission, for a macro fee, and then you can go and do what you want, and then we, liquidity providers, who will wait for the slow refund coming from the optimistic path. And the good thing about this layer is that it can also be an execution layer. So this is what we're focusing on. It's a layer that allows you to execute transactions on the destination chain, all with one click, all with a smooth experience for the user. So for example, you can do a bridge and deposit on the destination chain, a bridge and a swap on the destination chain, all in a very seamless way. This is how it works as an example. As I said, we use Ethereum as a central hub. So if you want to go for a Binance chain or a chain that is not directly connected to Ethereum, we apply an optimistic mechanism. So there is that's the most secure way to currently connect these two chains. And then if you want to go from ultimately to optimism, we plug into the native bridge. And in order to speed up the whole process, we have this fast network of fast liquidity providers that give you the cash immediately. So the beauty of it, as we wrapping up all the whole topic of this chat, is that with this type of technology, you can really build cross-chain applications. So it becomes a platform for developers to build cross-chain applications. The user interface is very simple. It basically tells you, okay, I want to interact with this smart contract on the destination chain with this token, and I want to do this. And so this unlocks really like a universe of possibilities. We really started to scratch the surface of what can be built. But I'm going to showcase you some examples of things that are being built and hopefully inspire more innovation and more things that you guys will actually develop. The first use case, as I mentioned, is what we call chain abstraction. So the idea that my dApp can only needs to be deployed on one chain, and then the users can be onboarded. The user can interact with my dApp from any other chain. So let's say that I have a vault, and I want it to be any users to be able to deposit from wherever chains they are. So from the thousands of layer 2s that will come up, I will not need to deploy on every single layer 2. I will just allow this onboarding, universal onboarding into my chain. And so I'm on another chain. I will only pay gas in the native token of the origin chain, but I'm able to interact with the dApp on the receiving chain, which kind of like simplifies and abstracts all the technological stack as we mentioned before. But this is just one example. You can do really a lot of things. One thing is cross-chain lending, for example, imagine a lending market that allows you to deposit collateral on one chain, ETH on Ethereum, and then allows you to borrow a stable coin on another chain, Polygon or wherever, because that's what the user wants in the moment. That's what the best rates are. Imagine a DAO that sets up its headquarters on a specific chain, but then has the necessity to manage funds on different chains. Now they can do it with this cross-chain communication in a very secure way. They can distribute the treasury if they want to pay their members on a different chain. They can change a parameter on a smart contract on another chain. They can actually deploy full smart contracts on the different chains. Imagine a project that is on an expensive chain like Ethereum mainnet that wants to go to another layer, another ecosystem to be able to fractionalize its NFT. Now they can do it, and it's very simple and it's very secure. So the idea is this is a generalized protocol that allows you to build a lot of good things, and we hope to spin this new wave of innovation for developers and builders. Okay, so that was the end of my talk. I just wanted to, leave this room with basically 3 takeaways. The first one is, every time that you think about cross-chain, you have to ask, okay, who has the power to rug me? Who can potentially corrupt this system to steal my funds? The second takeaway is, I want to build a cross-chain application because I want to be able to be composable with the whole ecosystem, with the whole series of universes that are coming out, the layer 2s, the layer 3s. I want to be able to access the liquidity. I want to be able to access the data that exists everywhere. And more importantly, I want to really simplify the experience for users. We are coming up to this fragmented universe. We're leading into this fragmented universe of Web3. We want to be able to abstract completely the technological stack for people. We want to be able to interact just with the dApps without having to think about chain. We call it chain abstraction. There is a toolkit that is already able to, where as a builder, you just need to import it. You don't need to do any additional audits because it's built on top. It's a layer built on top of your smart contracts, and it really changes the level of experience that you can provide to your dApp applications. Thank you so much. My name is Max. I hope you guys will get in touch, and if there are any questions, I'm happy to take them.